Okay, so again, today's Boehringer questions are going to be on the next Boehringer test. Make sure you have them starred in some way. We're going to talk about 5.1 and 5.2 vocab today. If you wanted to, when you get your assignment, you can either look up the terms in your textbook. I have a few copies over there behind Brandon and RJ on the TV stand. Or you can Google it, of course, with your phone. Just be warned. You know, sometimes when you Google stuff, you get way too much information and you're just overwhelmed. That could happen with this, so be careful. Careful. Okay, I don't like the title centers of triangles. We're going to make it more mathy. We're going to call it points of concurrency. Points of concurrency. A point of concurrency is where three or more lines intersect. We'll write that down in just a second. But really what we're talking about today is these 4 points in the middle of these 4 triangles. That's what we're going to talk about, the 4 points in the middles of each of these triangles. And that point is called a point of concurrency. The point in the middle is called a point of concurrency. Now, depending on how it was made, it has a more specific title. That's what we're about to talk about, like why it's called a circumcenter. This point of concurrency is called a circumcenter. This point of concurrency is called an incenter. This point of concurrency is called a centroid. This point of concurrency is called an orthocenter. There's a reason they're given those specific titles, and that's what we're going to discuss in the notes. But overall, if 3 lines intersect in a triangle at a specific point, that point is called a point of concurrency. And I would write that down at the bottom. 3 or more lines intersect at 3 more lines that intersect at the same point, that point of concurrency. Well, those lines are called concurrent lines. Okay. If we're adding it, that's my way of telling you it's on the vocab test. So I know there's a question that asks about concurrent lines. I know there's a question that asks about a point of concurrency. I'm going to be sweet and post like a practice vocab test on Google Classroom over the break. But I totally understand, happy Thanksgiving, you don't want to do math. So you're probably not going to look at it till next week. So next week when you watch this recording again, if you need to, I'm telling you, point of concurrency is on there, concurrent lines are on there. But you get a word bank. That's the good news. So, in fact, I would be so sweet as to even show you on the screen for a hot second. Word bank, 10 problems. You can make it 20 points in the 6% category. So it could change your grade 3 or 4 points. So my borderline one's at like an 89. This could push you down to a lower B. Or if you're at like a 91, this could bring you down to a B. If you're at like a 97, you're good to go. Hopefully. Okay, so we've got to talk about how these things happen. Why this one's called a circumcenter, why this one's called an incenter, why it's called a centroid. So let's pay attention to each picture. That will help. Okay, so the first thing is called a circumcenter. So the first blank here is circumcenter. And it's equidistant from each vertex of the triangle. And it's created by perpendicular bisectors. So I'll let you write that one, then we'll talk about what on earth that means. Okay, when you hear the word perpendicular, what do you think of? What kind of angles?
90 degrees.
Yeah, so notice all these right angles. When you hear the word bisector, what do you think of? Yeah, it cuts you in half. So notice that each of the sides is cut in half. Like CY is the same length as YB, AZ is the same length as ZC. So not only do they happen at right angles, but they're cutting the lines, the actual size of the triangle, in half. So that's how you ID it. So if you're looking at all 4 pictures, that's the only one that has right angles and all the sides cut in half. Centroid has all the sides cut in half. In-center has the right angles, but no other picture has all the right angles and all the sides cut in half. Perpendicular bisectors. Now, it's from the circumcenter is equidistant from each vertex of the triangle, meaning from M to C and A to M and B to M, those are all the same length. If I wanted to add dashes to those, I could. If I wanted to, like, I'll do an X marks the spot since they already did dashes of the world. They're all the same length. Now, if we were really doing this chapter for reals, you would start getting problems, and they'll tell you, like, AM is 14, and then you would have to say, oh, well, MB is 14, MC is 14 as well. But we're not actually going to have to do that. But I have seen, I mean, there are standardized test questions that exist on these points of concurrency, so it's not a bad thing to know. If I were to add a note at the bottom, just an FYI note that you probably don't have to memorize, it does not have to start at the vertex. But it can. Oh my gosh, I can't. Here we are. My little useful notes by the star, you don't really actually need to know that for a vocab test. All you really need to know for a vocab test is that perpendicular bisectors are made by circumcenters are made by perpendicular bisectors. And if we wanted to label it, that point of concurrency, we're calling it the circumcenter. Okay. Now I'm going to go ahead, because you're mature enough to handle it, and tell you my funny joke on how I remember perpendicular bisectors and circumcenter. I'm not going to write it down, though, because I'm not trying to get fired today. Circumcenter looks like circumscribed. Perpendicular bisector starts with a P. You know what I'm trying to insinuate now. Right? Okay. So, perpendicular bisector starts with a P. Circumcenter, circumscribed. Okay. If you got it, great. If not, you probably need to memorize that one. That's my hint on how I remember that one. Moving along, I promise there will be no more dirty jokes today. The rest of them are completely normal. Angle bisectors, let's see, in-center. The in-center is equidistant from each of the sides of the triangle. And it's created by angle bisectors. So the in-center is equidistant from each of the sides of the triangle, and it's created by angle bisectors. It has to start at a vertex. That's my only little note. Okay. You know an angle bisector cuts an angle in half. So if you start looking at the 4 pictures, this is the only picture that has each of the angles cut in half. So you know it's an in-center if all of the angles have been cut in half. This point is the in-center. Okay, so how do I remember angle bisectors and in-center go together? How do I remember those 2 words go together? I say angle bisecting happens inside the triangle. Angle bisecting happens inside the triangle. So far we have perpendicular bisectors and circumcenters. You can spot them because the sides are cut in half and you have the right angles. And we have in-centers and angle bisectors, and you can spot them because all the angles have the rainbows. So far, so good. Okay, the third one is centroid, woo. And it's created by something that we've not actually talked about before. It's created by a median. And we've never talked about that word. I slipped it on a few, like a note taker maker, but it's a problem we never did. I slipped it on another word. I've slipped it on two different things, but we didn't actually have to do those problems, so most people haven't done those problems. So, a centroid is created by a median connected to the vertex on the opposite side. So while we've never talked about the word median, you kind of already know what it is from hearing that word. What does median sound like? Middle. Notice that the median, look at point X, Y, and Z, they're happening in the middle of each of these sides. So we're going from the middle to the opposite sides of vertex. From the middle to the opposite sides of vertex. From the middle to the opposite sides of vertex. Those are medians. So they're easy to spot. And that point was called a centroid. And this is the one that I've actually seen a standardized test question or two on it, because there's a relationship with AM and MY. There's a relationship with the length of that segment. And the deal is that, here, let's probably list X, Y, and Z are medians. The deal is that the long side, like AM, is twice the short side, like MY. So that's darn why you don't need to know it for our vocab test. I have seen a standardized test question on that, because they'll tell you, for instance, AM is 6, so how long is MY? Well, it's half of that, so it's 3. Or they'll tell you ZM is 2, so how long is BM? Well, it's double that length, so it's 4. Or they'll tell you XM is 7, so how long is MC? Well, it would be 14. There is a relationship. And I've seen standardized test questions that ask about that. But you could have probably guessed it, because it kind of looks like a 1/3, 2/3 kind of thing. It looks like 2 XMs could fit inside MC anyway. Like if I picked up XM, it could fit here and here anyway. So you kind of probably could have guessed your way into it without me telling you. Okay, and my little cheat way to remember it is that medians happen in the center of the highway. So I'm trying to remember that centroid and median go together. So I say medians happen in the center of the highway. Okay, and the last one we're going to talk about today is an orthocenter, and it's created by an altitude. Yet again, another vocab term that we've magically skipped over so far with triangles. That's going to bother me. That needs an S. That needs an S. Okay, an orthocenter is created by a vertex connected to the opposite side so that it is perpendicular to that side. So you go from a vertex to the opposite side, and those two lines are perpendicular. You go from a vertex to the opposite side, and those two lines are perpendicular. That's all that's happening. So the picture, just if you're glancing between circumcenter, incenter, centroid, and orthocenter, orthocenter looks a lot like circumcenter, except circumcenter has markings on AX and XB and on each of the side links. This one has no markings. So the cleanest one is orthocenter. Okay, and if you had to make a note, it's pretty much the same thing you just wrote when you wrote perpendicular. We always start vertex, always start at vertex, makes right angle. Always start at vertex, makes right angle. Okay? And my way to remember that is the best one yet. The orthodontist makes you say ah. Orthocenter looks like orthodontist. Altitude looks like the word ah. So orthodontist makes you say ah. Dentist. Okay, so if we had to summarize on what Miss Compton did to you today, the Monday of Thanksgiving week, she handed you this handout and said you're having a vocab test next Wednesday. She said that all these terms are going to be on it, so she ought to be very specific yet again. She's going to tell you point of concurrency, you need to know what that is. You need to know what concurrent lines are. You need to know perpendicular bisector goes with circumcenter. We discussed how I remembered that. You need to know angle bisector goes with incenter. Angle bisectors happen inside a triangle. That's how I remember angle bisectors in center. Median goes with centroid. I remember that because medians happen in the center of the highway. Altitude goes with orthocenter because orthodontist makes you say ah. So those are the things you absolutely must know, are like the ones in each box. You need to know that they go together, that they're paired. Hence my note about how I'm remembering each. Are there any questions about this? I'm sorry to spring this on you, but like I've said, we're kind of behind. Last year I was already